Hello, Rest Africa Hackathon. Yeah, my name is Fraul. I'm from Ethiopia, and I'm going to be demoing our project Ersha OS to you guys. So yeah, let's get started with it. So the idea actually came up when we were discussing about this, I think on January 2. This is actually our discussion group on Telegram with the rest of my teammates. Basically, our idea was there is this growing trend of digital public infrastructure across the world with national ID systems and with like digital currency systems and stuff like that. So basically, the idea is that like the same in the same way like governments provide roads and like rail networks and stuff like that for the development of a country, they should also provide like some digital infrastructure that the rest of the economy can build upon and build the country and build like further develop the country with. So there are one of these systems is MOSIP for national ID and stuff like that. We actually have a system like that in our country in Ethiopia. But basically our idea was to create a system. We call it Ersha always because Ersha in Amharic is farming. That's like in Amharic, in Amharic is called Ersha. So we call it Ersha always or Ersha operating system. So basically, what this system does is it's. So let me scroll down to the architecture. So it has three tiers. We have the H tier, we have the dispatchers tier, and we have the central tier. So basically one of the biggest problems with systems like this is that they give a lot of responsibilities to the edge devices, to the actual devices where the where the sensors and the actual microcontrollers will be deployed. But that's not really a scalable approach because those things end up being expensive, and one of the most expensive parts of that bill of materials is going to end up being the networking parts, like adding a Wi-Fi card and stuff like that, and deploying like millions of those devices becomes unfeasible. So our plan was to separate it out into a separate tier architecture where each tier handles a specific concern. So the H tier, its concern is just coordinating with the sensors and actually collecting the data, and it reports the sensors, the edge devices or the sensors actually report to the dispatchers using like radio-based cheaper network devices like LoRa devices and stuff like that, and then they use that to send their sensor readings to the dispatcher tier. The dispatcher tier, you can think of them as like nodes in different regions. So in a given region, there will be a set of devices or sensors deployed across all over that region, and all of them send radio waves to this dispatcher, which will be a single like actual computer on a given region, and then in that region. And then that dispatcher basically is responsible with connecting to the actual internet and then sending the sensor readings received from the edge devices. So we move the actual heavy compute and network dependent stuff to another machine, the dispatcher layer. So the dispatcher layer, even though like these are supposed to be even though these are like central computers in a given region and stuff like that, they might not be able to they might not have 24 hours like internet access or something like that. So another responsibility of the dispatcher is also keeping the data locally, and it only sends uploads the data to the central system once it gets actually connected to the internet, or once it has an internet connection. So that's the responsibility of the dispatcher described here. Let me open up the image in a new tab so that we can see it clearly. And then in the central tier we have two components described here. Ersha Prime. So Ersha Prime is the main like actually data ingester of the system. It has a bunch of registries: the device registry, dispatcher registry, and the readings and device statuses registry. So it also receives device statuses from the edge devices, like if their battery is low, if there's a broken sensor and stuff like that. So that's what the central tier handles. So it collects all of those, and all of this stuff, the dispatcher's storage system, the Ersha agents like interaction with the sensors and stuff is all like standardized behind a bunch of trait implementations, so they can easily be switched by other vendor providers or like other implementations. For example, in the current system we have SQLite and in-memory support for like the system that like persists the data like for in terms of like when to handle like the interconnectivity issue. We have a backup system that stores the data locally on Ersha dispatch, but that's like that interaction is handled through an trait. So if we wanted to like use like a network attached storage or something like that, we can easily switch that out by adding another implementation of that trait. So we do the same thing in Ersha Prime. Each registry is just a trait and it has multiple implementation. For the current system, we implemented a ClickHouse implementation for it, because after comparing Postgres, I think that's the main one we looked at, and ClickHouse ended up being the actual winner in terms of storing these kinds of data, because we're going to be working with a bunch of data in this system. And then so Ersha Prime basically collects all the data and ingest that to ClickHouse. It also does a bunch of validation, it doesn't just receive any data from any dispatcher. It has a registry of dispatchers and edge devices and dispatchers. So if it doesn't know about if it receives data from a registry or a dispatcher it doesn't know about, it will not like take in that data. It will discard it. So we have a separate registry system. So this is what is described here. We call that the Ersha registry. You can define you can, like, once you deploy an edge device or once you deploy a dispatcher to a specific location, you can register that using the Ersha registry. And then all of that data gets ingested into ClickHouse. After that, we are thinking of like different ways of implementing a dashboard, but we just the final decision we decided to go with was this system is supposed to be infrastructure, so it should not be concerned about creating like the final end product of this that will be created using this data. Like a final end product with this would be like climate monitoring system based on these sensor readings, or farmer alerts for like irrigation and stuff like that. So we shouldn't be concerned about that. So we just optimized on like getting the data as safely and reliably as possible. So what we decided on was using Grafana for the dashboard. I'll be demoing that a bit later. And then we also have a bunch of supporting crates in this repository. We have the core system where we defined all of our shared types in there. We have the Ersha RPC system. I can go back here. Yeah, we have the Ersha RPC system here, which is basically our own custom. We created our own RPC system based on TLS and TCP streams for the communication between the Ersha dispatch and the Ersha Prime systems, because we wanted to optimize bandwidth. Like I said, even though the dispatchers are expected to have an internet connection, the bandwidth is going to be heavily limited because they're going to be in rural areas. So in order to not like waste any data like with HTTP headers and stuff like that, if we use the HTTP headers, we don't have wasted a lot of data we don't actually care about via like HTTP headers, HTTP all the fluff around it. So we decided to create our own RPC implementation. I'll be showing that also. And to secure the communication between the dispatcher and the Prime on the Prime server, we created a mutual TLS system. We call that Ersha TLS. Basically, both of them have their own architectures that both of them know about. So they validate it's like the thing that's actually connecting to Ersha Prime and sending the data. We actually can confirm that that's a valid known dispatcher via our TLS system. And then for testing, we created this Ersha dispatch harness. Basically, that's just gonna, since we're not gonna be using an actual real device in this demo, that's gonna be a system that just creates a bunch of dispatchers, a bunch of devices, and sends data to Ersha Prime. I think I'm already at 10 minutes. Oh, sorry. Okay. Yeah, I hope this will be shorter. But to read more about this, you can go to our repository, and each crate has actually its own README. Each of them take their own config values. You can configure a bunch of stuff about these systems. So yeah, so let me actually go into the live demo. So here we have, so I've actually run the system with Docker Compose locally here, and here we have it running. So we can see a bunch of these like readings being sent here. So these are like simulated readings, and we have 100 devices currently, 10 dispatchers. Each 10 dispatcher also has 10 devices. That's where the data is being sent from. I also am simulating some unknown dispatchers. That's why we see the error count here. If it doesn't know the dispatcher, like I said, it will reject it. So let me go to the dashboards and show you the other dashboards we have here. So we have a device health dashboard. Basically shows the error count, it shows the battery levels across time, because like I said, we're not just collecting the sensor data, we're also collecting the data about the device sensors as well. So we can see their uptime, we can see their signal strength because they're going to be using Wi-Fi most of the time. We can see their signal strength here. And then if we go to the dashboard, we have also this. Okay, let's go to the sensor reading. So these are the sensor readings we're getting. So these are the average values we're getting. So we have a bunch of sample sensor data like implemented here, like humidity, soil moisture, soil temperature, and this is all the data that's being currently sent out by the mocking service I talked about earlier. So all of that is being, so we can make sure, we can know that the system is actually working correctly. And then we have this world map. So basically what makes our system, another thing that makes our system unique is we relied on Uber's H3 indexing system. Basically what that is, depending on your resolution, it splits up the world into a bunch of hexagonal regions. And because I was talking, I mentioned that dispatcher is responsible for a specific region, and that region in this case is a specific H3 cell. So in its H3 cells, it will have a bunch of devices deployed there, and what this allows us to do is we're not actually locked into a specific latitude or longitude value, because since these things are going to be like in a highly dynamic situation, they can be moved around easily, and because we're not specifically dependent on latitude and longitude value, we can move them anywhere around that given cell or region I talked about earlier. So here we have a map of the dispatcher. Like I mentioned, we have 10 dispatchers in this in the example like system or the Ersha dispatchers harness thing I talked about, mocks data being sent by a bunch of dispatchers from across the Ethiopia. So that we have one around here. Let's go to it. So this is the dispatcher. We can see its name, basically it's the location, the latitude, which is not actually stored on the device. We can infer the latitude and longitude based on the H3 index and the H3 resolution in which it was placed at, and how many devices it has. And then here we have the devices that it's actually responsible for. I can go down here and see 10 devices here. I think they're saying, but yeah, we have. So this dispatcher is responsible for these devices. So that's how the system works. So each of them send their data to this dispatcher via radio signals like LoRa I talked about earlier, and then each dispatcher sends it to the central service or the prime server. That's how our system works. So yeah. So, and then another thing this allows us to do, our H3 based in the location indexing system, what that allows us to do is we don't actually have to ship a location or a GPS sensor, a GPS module with our like MCUs and stuff, because their location is going to be known so we know where they're going to be deployed. So we can just specifically tell them that you're going to be operating at this H3 cell, which is generated at this resolution. So we can specifically just configure that before we deploy them. So that removes the need for having a GPS system on those devices. So here we can also see the readings, because their device sensor, their device also has a location. We can also attach a location to a specific reading. So you can see this system being used to create a heat map of like soil temperature across Ethiopia or something like that, and it could actually be used to create to not just to help farmers, but to create like early warning systems for droughts and climate change, stuff like that. So that's why we're calling this like a digital public infrastructure. We're just collecting the data, because most of the time when people try to solve problems like this, always the problem is like, how are you going to get the data, how are you going to get the data? But if we create like an infrastructure or system like this, it will make the data available for any kind of application layer stuff we might need to do in the future. So this is our dashboard, and currently the alerting system is not completely done yet. We are planning to have like SMS based and Telegram and WhatsApp based alerting systems. But here we have also we can use we're planning on using Grafana's alerting system. So we have a bunch of these alerting rules set up here. So yeah, we can actually use this in the future to integrate it with like alerting systems in the future. So this is what we have. Yeah, so the data is actually coming in. Yeah, so we can see them right here. So okay, so this is the dashboard, and another component I was talking about here is, if I go back to the diagram, we have the Ersha registry, which is actually implemented in Elm, and we tried to do Rust, but we actually backtracked and used Elm for this, because you gotta use the right tool for the right job. So this is our registry. So it's currently showing the 10 dispatchers we have and the 100 devices that have been registered here. We can add a new device. We can give it the device ID. We can give it their H3 location. We can give it the manufacturer, which manufacturer created this device, and what kind of device it is. We currently only have sensors, but in the future we will have actuators so that we can control irrigation systems and stuff like that. But currently we're just a monitoring system. And then we can also add dispatchers here. We can give it the dispatcher ID and its H3 sale index I talked about earlier. So this is our system. Yeah, I don't think I missed anything. Yeah, this is all I wanted to say, I think. Yeah, so just a little bit of in terms of like actually running this project, we haven't actually deployed it to anywhere. We've all just been working with it locally. So yeah, I mentioned that it does depend on ClickHouse. We have a bunch of adjust file here on the project's routes that has a bunch of tasks that we were using when we are working on this project, like specific commands to build the system, run the system, test the system, and stuff like that. We're also using Nix. Which is like a way to declaratively create like your developer environment, and basically just specify a declarative system to specify software dependencies and stuff like that. So yeah, we've been conscious of doing stuff like that, so that this can actually be reproducible and reusable. Yeah, and then basically we have this just docker bootstrap command, which will actually set up everything and run the system for you on your device. If you wanted to do that, we can do that. And like I mentioned, there are a few things we want to handle in the future. Currently, because because we were limited by our hardware availability on our side, we didn't actually go down the road of, we didn't get the chance of implementing a LoRaWAN transport, even though that's what we were trying to do. Instead, we have a Wi-Fi and TCP based implementation, which is I think based on the RP420 embedded system that one of our teammates did. So we have that there, and we also are planning on alert system delivery and stuff like that. The alerting system I talked about earlier, we're also planning on implementing that, and we're also planning on having a hardware reference design so that actual vendors and manufacturers can create these dispatchers and sensor devices with these. Yeah, so that's what I wanted to say. And we also have a release where we released all of the binaries. So if you specifically wanted to experiment with the Prime server or the dispatcher server, you can download them from here, from the release page, and try them out. And then to mention our teammates, so these are our teammates: Omar, Taylor, and Brad. So, and then I'm Fraud. So see, this was our project. Ersha, thank you very much.